Hey guys, so we are on week 1 of quarantine notes. What I did was I took your notes and I put them into a PowerPoint. I kind of cut down what your normal notes would be, and this way I can kind of talk you through them without you trying to decipher them yourselves. If you like this, let me know. If you hate it, let me know. If you don't care, let me know, and we'll kind of see how it goes from here. So, if you remember, before we had our nice break, we played around on Desmos with domain and range, and you had stuff that looked kind of like this. And we didn't get to the actual really good part of it. So remember that domain is your X values. So domain is all the values that the graph covers from left to right. And range is Y. And so range is all the Y values that the graph covers, and we go from bottom to top. So we're going to look at a couple examples with domain and range. And what it's going to look like is it's going to give you a graph. And it's going to say use the graph to determine the functions domain, range, x-intercepts, y-intercept, and then it'll say something like f of 2 or f of 5 or something like that. And so we want to answer those things. So first of all, domain wants to know what x values does your graph cover? So this graph, if I look at the end of it here, it's going on forever. So I look at how far to the left my graph goes. Well, since it's going on forever, that would be negative infinity. And then it goes and it goes and it goes and it goes until the right. And so it's going on forever to the right, which would be positive infinity. So its domain would be negative infinity to positive infinity. And infinities always get parentheses, remember. So that's my domain. Range is your y values. So how far down does my graph go? Well, the furthest down it goes is -4. And it actually touches -4 there. So I give -4 a bracket. And then how far up does it go? Well, it's going up forever, so infinity. Infinity always gets parentheses. X-intercepts, where does it cross the x-axis? Right there at -3, right there at 1. You'll notice my graph's counting by like 1/2, so -3 and 1. Y-intercept, where does it cross the y? Down here at -3. And then this last one, f of 2. What that's saying is, what is y when x is 2? So if I come over here to where x is 2, I want to see where my graph crosses there. So I come up here and it looks like this point right here, which my answer is not right there. So it looks like it's probably about 5. So that should definitely be a 5. Can I change that? Ooh. Is that a thing? Nope, apparently not. All right, next example. Same idea. Here's our graph, and we want to find domain, range, x-intercepts, y-intercept, and again, f of 2. So domain, how far to the left does my graph go? Well, it stops right here at where x is 0. So I'd give it 0 with a bracket. And then it goes on forever to infinity. Range, how far down does my graph go? Well, this is the furthest down it goes, which is where y is 1 with a bracket. And it goes up forever, which is infinity. X-intercepts, it never touches the x-axis, so there are none. Don't write 0 because that makes me think your x-intercept is 0. Y-intercept, it touches right here at 1. And f of 2, if I come over here to 2, it's a little more than 2, 2.5, I don't know, eyeball it. Give it your best guess. So that's how we're going to use graphs to find stuff. Domain and range are probably the hardest parts there. How far to the left, how far to the right. Range is how far down to how far up. All right. The other thing we're going to do is polynomial long division. Oof, fun. So when we do polynomial long division, it's just like 4th grade long division. Same steps. It just has x's in it. So the first thing you want to do is write it like 4th grade long division. So you put whatever you're dividing in the box and whatever you're dividing by. So we're doing x squared plus 10x plus 21 divided by x plus 3. The first step is the hardest. You want to say, what does this x need to turn into this x squared? What do I multiply this x by to give me x squared? Well, I know that x times x gives me x squared, so I put an x on top. And then we multiply x times x and x times 3. So x times x is x squared plus x times 3 is 3x. And then once we've got that written underneath there, we subtract. So x squared minus x squared is gone. 10x minus 3x is 7x. And then we're going to drop down that 21. Okay, so then same step we started with. What does x need to be 7x? What do we multiply x by to make it a 7x? A 7. And then we multiply again. 7 times x, 7 times 3 is 7x plus 21. Subtract, and we get a remainder of a 0. So my answer is x plus 7. Hooray! That one's pretty easy, right? So let's do a tough one. We have 6x to the 4th plus 5x cubed plus 3x minus 5 divided by 3x squared minus 2x. First of all, when you write this down, you're going to notice I've put in some zeros. If you put those placeholders in, it's just going to make things easier for you. So I'm missing an x squared here in between 5x cubed and 3x. So I put in a 0x squared. 3x squared minus 2x doesn't have a constant, so I put in a plus 0. It's just going to make stuff line up easier. So I start out the same way. What does 3x squared need to be 6x to the 4th? Well, I need to take 3 times 2, and I need to take x squared times x squared. So up on top, I'm going to write 2x squared. And then we multiply 2x squared times this whole thing. So 2x squared times 3x squared is 6x to the 4th. 2x squared times negative 2x is negative 4x cubed. 2x squared times 0 is 0x squareds. And then you can see in orange, I changed that to subtraction. So my minuses become pluses. My pluses become minuses. My 6x to the 4th disappear. 5x to the 3rd plus 4x to the 3rd is 9x to the 3rd. 0x squareds become nothing. And then I drop down my 3x. So what does 3x squared need to become 9x to the 3rd? Well, it needs a 3 and another x. So I put a plus 3x on top. So 3x times 3x squared, that's 9x cubed. 3x times negative 2x is negative 6x squared. And 3x times 0 is 0x. And then in green, I changed that to subtraction. So my 9x cubes are gone. 0x squared plus 6x squared is 6x squared. 3x minus 0x is still 3x. And you drop down your minus 5. So one more time, what does 3x squared need to be 6x squared? Well, it just needs a 2, which seems to be missing from up here. Guys, sometimes I struggle, sorry. So we multiply our 2, and you get negative 6x squared, 4x and 0, subtract, and you end up with 7x minus 5. That is your remainder. What do you do with a remainder? You don't write R, and you don't turn into a decimal, because we don't have decimals with equations. So what you do is you put that over what you're dividing by. So your answer is 2x squared plus 3x plus 2, which I'm an idiot and didn't put in there, plus your remainder, 7x minus 5, over what you're dividing by, 3x squared minus 2x. That's how you do polynomial log division. And this one's pretty bad. This is as ugly as they're going to get. So if you can do that, you're good to go this week. Those are notes for the week. So if you get on my math lab, you'll see homework week 1. That's what you can work on now. Next week, we're going to do a little quizaroo over this stuff, and we're going to be graphing polynomials and rational functions. Not next week, but the week after that, we're going to be doing our Unit 4 test. I will have a review for you next week to get you ready for that. All of our quizzes and tests are going to be on my math lab because that's kind of the only way we can do them. If you have any questions, you can email me. When you go to like question help on my math lab, there's one that says ask my instructor, and it will send me the exact question that you're working on, and I can email you back right then and there as long as I'm not busy. If you want to set up a time that we can video chat and I can help you out with that, we can do that. You just let me know what I can do to help you. Whatever you need, I am here for you. So work on that stuff. Let me know what you need. Do your best. You can do this. I have faith in you.